Today, we're taking a look at a very interesting type of laser engraver, the WeCreat Lumos Ultra. This is the world's first all-in-one UV plus MOPA laser system, combining two very different laser technologies in a single machine. Compared to separate systems, it saves over 35% in cost, reduces switching time by more than 90%, and takes up around 50% less space. It features a 6-watt UV laser, which is perfect for engraving plastics, glass, wood, and leather without leaving burn marks. The UV laser can also make stunning embedded 3D glass crystal engravings, which can make for an excellent and memorable gift. On top of that, it also supports a separate MOPA fiber laser add-on, which excels at engraving all types of metals, either quickly or with significant depth, and is also highly effective for rust removal. It can even produce colored engraving in stainless steel and can make deep engravings in stone. The fiber laser module connects to the machine by inserting the output collimator head directly into the unit. Fiber lasers are the best choice for engraving metals, and in my case, I have a 100-watt JPT MOPA laser source here that I'm really excited to test. In this video, I will also test the slider extension and rotary attachment. And if you enjoyed this video, leave a like and consider subscribing for more content like this. The machine comes with 3 lenses, a purple 200mm lens for surface engraving, and a green 70mm lens for 3D inner glass engraving, both to be used with the UV laser, and a red 200mm lens for engraving metals with the fiber laser. On the back of the machine, you'll find all the necessary connections for accessories. Near the top, there's also an opening for inserting the fiber laser's output collimator head, which I'll demonstrate later in the video. The Lumos Ultra also comes with one of the nicest rotary accessories I've seen so far. The outer part of the chuck is made from a very grippy soft rubber, which is ideal for holding glasses from the inside. You also get long pins for holding rings, as well as small and medium grippy pins, rubber chuck jaws, an adjustable support for longer objects, and another support arm with 2 ball bearings. In addition, there are a few extra accessories included, such as a cutting plate, angled positioning brackets, and an exhaust venting hose. The machine can be controlled using either the WeCreat Make It software or Lightburn. Normally, I'm quite skeptical of proprietary software, since it's often not very refined. But in this case, the WeCreat Make It software runs very smoothly and feels well designed. It includes all the necessary features you need to get the most out of the machine. The Lumos Ultra can also be used with Lightburn, although advanced engraving modes like 3D glass engraving are not supported there. Let's start by testing the claim that this machine can engrave high-resolution images using the UV laser. I imported a photo, adjusted it, and converted it into a negative. The software also includes useful editing tools like background removal and cropping. I engraved the image onto black engraving paper, and it only took a few minutes to complete. My first attempt came out a bit too bright, so I adjusted the parameters and got a perfect result. It's honestly unbelievable how much detail a UV laser can produce. Next, I wanted to see how well it performs on jeans fabric using the UV laser. The design was engraved in about a minute. Before taking a closer look, I refreshed the camera preview to check how accurately it aligns with the design, and the alignment was perfect. I didn't expect it to be this precise. Looking more closely, I did notice some burn marks, but that was entirely due to my design. It included very small flowers with extremely thin lines, and I had enabled an option to trace outlines after a fill engraving. Because the flowers were so small, this caused some burning. Aside from that, the rest of the design turned out great and is comparable to other lasers I've tested. UV lasers are far superior to diode lasers for fabric because they don't damage the fibers. The brown engravings you often see from diode lasers are actually caused by fiber damage due to the heat, which weakens the material. But a UV laser can only remove the dye color and leave a perfect white mark. One feature I really like is the focusing control knob. The machine has autofocus, but if you want to adjust it manually, you can use this knob to control the Z-axis height. What's especially clever is that the more you rotate the knob, the faster the Z-axis motor moves. Small adjustments allow for very fine control, which makes the process very precise. The machine is in focus when two dots align on the surface. I also tested cutting wood using the UV laser. Cutting 4 millimeters thick wood requires around 18 passes at a speed of 100 millimeters per second. For filming purposes, I ran the machine with the lid open, but I wore high-quality safety glasses to protect my eyes. Even though 18 passes might sound like a lot, the high speed means the cut is completed very quickly, and this footage is shown in real time. The result is incredible. UV lasers can cut wood with extremely high precision and absolutely no burn marks. The cutting kerf is also minimal. I then tried cutting 5 millimeters thick solid beechwood. On my first attempt, I didn't increase the number of passes so it didn't cut all the way through. However, this actually demonstrates just how tiny the cutting kerf is. When I split the wood, you can see that the cut is perfectly smooth and completely free of burn marks. Here's a comparison between this cut and the one made with a high-end 40-watt diode laser. The difference is like night and day. UV lasers are also excellent for engraving plastics because they don't melt the surface. One of the most profitable applications is engraving plastic lids for homemade cosmetics. Here, I have a cream jar with a white plastic lid, and it engraves beautifully. Plastic also engraves very quickly, allowing you to produce large quantities in a short time. The level of detail is impressive. UV lasers also perform very well on real leather. By using layer functions in the software, I applied two different parameter sets to different parts of the design. One was engraved at a slower speed to create a darker effect, while the other used a higher speed for a lighter tone. Another great feature of this machine is the ability to preview designs using two different lasers. The UV preview is extremely sharp and precise, but it can be hard to see on certain materials. In those cases, you can switch to a red light preview, which is more visible but slightly less precise. I ran the engraving, and it completed in about a minute. The result matched my expectations perfectly, producing a clean, two-tone, and durable engraving. This machine uses a 200mm lens for surface engraving, so I wanted to test how well it performs on glass. Larger lenses slightly reduce beam energy density, which can make glass engraving more difficult. However, despite having only 6 watts of power, the machine handled it with ease. The result is as good as it gets, a deep, durable mark with excellent clarity. Unfortunately, I forgot to rotate the design, so it's only properly oriented when drinking from the glass. I also tested laser engravable tamper-proof sticker tape. WeCreat Studio is capable enough to create simple and beautiful designs like these in a matter of minutes. Using a fill pattern for the text and a slower line pass to cut the outer shape, I achieved excellent results. The engraving quality is perfect, and the cut didn't go through the backing material, which is exactly what I wanted. The sticker adheres very securely, and any attempt to remove it damages the label, just as intended. This is something you could easily sell to local businesses. Next, I swapped to the green 70mm lens, which is used for 3D inner glass engraving. Because this lens has a much shorter focal distance, you need to mount spacer legs on the work table to bring the object closer. First, I tested 2.5D inner glass engraving. You start by entering the dimensions of the glass object, then import a photo or create a design and adjust it to fit. I used a photo because I was curious how the machine would interpret depth from a flat image. During engraving, the machine is adjusting the Z-axis height for each additional layer. The process took several minutes to complete, but the result is absolutely stunning. The level of detail far exceeded my expectations. The engraving looks equally detailed from both sides, but what's really interesting is the side view. It seems like the software uses some form of AI to generate a 3D effect. For example, one of the dog's front paws is engraved slightly higher than the other, and the muzzle protrudes more. The machine recognized the subject and created a more realistic 3D representation. It's genuinely impressive. Then I moved on to engraving a full 3D inner glass design, which is honestly one of the coolest things a UV laser can do. The process is very similar to the 2.5D engraving mode, so I won't go over all the details again. Full 3D inner glass engravings do take more time to complete. This one took around 40 minutes. But the final result looks incredible. Using this method, you can create truly unique personalized gifts. Next, it was time to connect the MOPA fiber laser module. The setup process is very straightforward. You simply connect the communication cable and power cable, then insert the fiber laser's output collimator head into the machine. When using the fiber laser, you also need to install the red 200mm lens. The fiber laser module performs best on metals. This 100-watt JPT fiber laser source is incredibly powerful and can create deep engravings very quickly. MOPA laser sources are also highly adjustable, and changing the parameters can produce dramatically different results. Here, I ran a second cleaning pass which completely cleaned up the engraving and left behind a bright white finish. This cleaning effect also works extremely well for rust removal. I tested 2 different parameter sets, and they produced very different finishes. One created a clean matte white appearance, while the other produced a polished metallic look. After that, I tested the deep embossing mode in brass, which creates a 3D effect by applying more engraving passes to the darker areas of the image. I ran 128 layers at maximum power, with a few cleaning passes every 10 layers. The result was a very nice 3D engraving approximately 0.7 millimeters deep. This type of engraving is ideal for making jewelry and custom decorative pieces. The fiber laser also works very well on stone. Using high speed and full power, you can create deep engravings in a surprisingly short amount of time. This footage is shown in real time. Deep embossing on stone is also possible, and the final result looks fantastic. Another impressive feature of a MOPA fiber laser is its ability to create colored engravings on stainless steel. This works by heating the surface very precisely, forming a thin oxide layer. The thickness of this oxide layer determines the resulting color. Using the built-in pattern generator, I was able to produce several colors after only a few test runs. With more experimentation, it should be possible to achieve an even wider range of colors. Next, I tested the rotary attachment. This is honestly one of the best rotary tools I've seen so far. It comes with a wide variety of jaws and even features grippy rubber surfaces on the chuck itself for securely holding large vases and glasses. For this medium-sized jar, I used the rubber pins to mount it in the chuck. The software is very intuitive to use and even provides a 3D preview of the design before engraving. During operation, the rotary spins very smoothly, and the final result came out exactly as expected. You can also engrave small rings using the pin jaws. In my case, I accidentally mounted the rotary on the wrong side of the machine, so the engraving came out mirrored. But, aside from that mistake, the engraving quality itself was excellent. Finally, I tested the slider extension accessory. It is very well made and uses a quality linear guide screw instead of belts, which gives it way more precision. It mounts onto 2 positioning pins that screw into the machine bed. When refreshing the camera preview, the machine automatically slides the entire extension under the camera, allowing it to capture a full overview of the enlarged work area. I engraved a simple design onto fluorescent scratch paper using the fiber laser. This accessory extends the usable X-axis working area to an impressive 52 centimeters. The result came out perfectly, and after exposure to sunlight, the material even glows in the dark for a while. Overall, I'm genuinely impressed with the WeCreat Lumos Ultra. The combination of a UV laser with an optional MOPA fiber laser makes this a very versatile machine that can handle an incredibly wide range of materials and applications. The software is easy to use, the accessories are well designed, and features like the rotary attachment, slider extension, and dual laser preview make the whole workflow feel very polished.